In a river where currents never sleep, a creature moves through shifting water with a kind of quiet certainty, sensing changes long before anything becomes visible. The trout does not rely on strength or speed alone. Its true power lies in the way it interprets the world around it, reading signals woven into the river itself. To most of us, a stream is simple, just flowing water, but to a trout, it is a layered landscape filled with pressure, vibration, chemistry, and light, each carrying information. The world it lives in is not chaotic, but structured, a living map shaped by physics and biology that few creatures understand as deeply as trout do. Everything the river does, every push, pull, twist, and ripple, becomes part of a language the trout has learned to read since the moment it hatched. This connection between fish and water begins with the lateral line, a sensory organ so delicate it can detect disturbances imperceptible to human senses. Running along the trout's body, the lateral line acts like a continuous antenna, picking up vibrations that travel through water with remarkable clarity. A small insect landing on the surface, a predator shifting its weight upstream, or a stone altering the flow, all of these generate patterns the trout instantly interprets. In darkness, in muddy water, or beneath deep overhangs, the lateral line becomes a second form of vision, guiding the trout through obstacles it never truly sees. Even the presence of a rock creates a pressure shadow, which the trout senses as sharply as if it were looking at a visible object. But vibration alone does not tell the whole story. Trout also read hydrodynamics, the hidden geometry of moving water that reveals shape through motion. When water flows around an object, it forms eddies, vortices, and microcurrent structures the trout can feel, almost as if touching them directly. These patterns allow trout to predict where food might drift, where predators might hide, and where safety lies in the shifting rhythm of the river. Hydrodynamic sensing also lets trout conserve energy, finding pockets where water supports them, allowing effortless hovering in strong currents. Watching a trout hold still in rushing water is witnessing sensory precision, not brute strength, as it balances on invisible architecture. Yet the river is vast, and vibration and flow are not enough to navigate it fully. For direction, trout rely on something far older Earth's magnetic field. Inside the trout's tissues are crystals of magnetite, aligned with the planet's magnetic lines, giving the fish a built-in compass that operates continuously. This internal compass helps trout orient themselves even in murky tributaries where nothing looks familiar, guiding them through networks of streams. During migration, magnetoreception becomes essential, pointing trout towards spawning grounds with accuracy that surpasses human intuition. Even after years at sea, they can feel the magnetic signature of their home river and begin their journey back with precision that still puzzles biologists. But direction alone cannot reveal the presence of other creatures. For that, trout depend on electrosensitivity, the detection of faint electrical signals produced by life. Every muscle contraction, every nervous impulse, generates electrical pulses, and trout can sense these subtle fields in the water around them. This ability allows trout to locate prey hidden in silt, behind rocks, or buried in submerged vegetation when visibility disappears. Electrosensitivity becomes even more important during night or flood conditions, when sight becomes unreliable and sound is distorted by turbulence. To a trout, electricity is not a mystery. It is another layer of awareness, revealing movement that eyes cannot track. Chemical sensing adds another dimension. Trout have an extraordinary sense of smell, capable of detecting molecular concentrations so low they seem impossible. Every river has its own chemical identity, shaped by geology, minerals, and organic life, and trout memorize this signature early in development. Years later, they return to the same waters, guided by the faint chemical traces drifting downstream, following scent trails invisible to all other animals. This scent-based memory is so strong that trout can differentiate between two streams that look identical to human eyes. Chemistry allows trout not just to move through the river, but to understand it, recognizing when conditions shift, when danger approaches, or when food becomes abundant. And then there is ultraviolet vision, a sense that expands the trout's perception into wavelengths humans cannot see. To trout, insects reflect ultraviolet patterns that glow brightly, making them easier to detect even in dim light or turbulent surface water. UV vision also helps trout identify predators and navigate complex environments, reading reflections and light angles hidden from our sight. The river surface reflects ultraviolet light differently depending on depth, current speed, and clarity, giving trout subtle cues about where to rise or where to avoid. These ultraviolet cues create a visual world we cannot imagine, filled with shimmering signals layered atop flow and chemistry. Each sense on its own is remarkable, but together they create a perception system far more sophisticated than any single tool. The trout does not switch between senses. It integrates them, forming a unified understanding of its environment in real time. A vibration detected by the lateral line may be confirmed by an electrical pulse, refined by hydrodynamic structure, and verified through chemical cues. Its brain receives this flood of information and processes it with efficiency honed by millions of years of evolution. The result is awareness that feels almost intuitive, a sense of the river's entire shape, mood, and rhythm at any moment. This integration allows trout to react before events unfold, rising to catch insects when timing appears perfect, yet is guided by several senses working together. It lets them slip away from predators before danger becomes visible, reading subtle shifts in water pressure long before a threat takes shape. And it helps them choose holding positions where energy use is minimal, allowing survival in fast, cold, nutrient-poor environments. Every movement the trout makes is informed by layers of invisible data, shaping behavior more precisely than any conscious calculation could. To human observers, this awareness can look like instinct, but it is far more complex, an interplay of sensory systems communicating constantly. Evolution sharpened these systems over millions of years as trout faced shifting currents, harsh winters, hungry predators, and unpredictable floods. Only individuals with the most refined senses survived these challenges, passing their abilities to generations that followed. Over time, perception became trout's greatest strength, turning them into master interpreters of freshwater systems. The river shaped them, and in return, they learned to read the river more deeply than any creature alive. Their world is a conversation of currents and signals, and trout are fluent in its language. Each glide through the water is not just movement, it is interpretation, translation, and understanding. Their bodies are tuned to forces we barely perceive, revealing a side of nature hidden beneath the surface. In every stream, a trout listens not with ears, but with its skin, its nerves, its eyes, and its memory. It feels the world through vibration, sees it through ultraviolet light, navigates through magnetism, and remembers it through chemistry. What seems like simple behavior is actually the product of a sensory network unrivaled in freshwater environments. And as the river continues to flow, changing with weather, season, and time, the trout adapts effortlessly, guided by senses built for a world in constant motion. It is a creature shaped by water, reading the landscape not with sight alone, but with perception woven through every part of its being. In the end, the trout does not just survive the river, it understands it.